June 2010, algebra question number 3. The energy E joules released by an earthquake of magnitude R on the Richter scale can be modelled by the equation E equals K multiplied by A to the power of R, where K and A are constants. For this model, show that ln E equals ln K plus R ln A. Right, so the first thing we'll do is just write down the equation. E equals K times A to the R. And then we'll take ln of both sides. So that means ln of E equals ln of K multiplied by A to the power of R. Okay, so the left-hand side is good now. That's just ln E. The right-hand side we need to break down a little bit. Remember, when you times two things together inside a log, you can write them as two separate logs added together, ln K plus ln A to the R. And then the other rule of logs is that if you've got a power up there, that can be brought down the front. So that gives us ln E equals ln K plus R ln A, as required. Right, part B of this question. Complete the table of values, giving the values of ln E to 3 significant figures. Okay, so for this we're going to need to use the calculator. So let's bring that up. Okay, so what we want to do is basically take ln of each of the numbers here. So that means do, for example, ln of, now this number here is in standard form, which means we'll need to enter it into the calculator in standard form. So to do that, just kind of write it really as it's written there. So ln of 1.34. Then we use this times 10 to the power of button. So times 10 to the power of 8. Okay, close bracket like so, press equals, and we get 18.7. So I write that in there, 18.7. Notice it says 3 significant figures that they want the answer to. So on here you've got 18.71, so that's going to be 18.7 to 3 significant figures. Okay, so then you just need to fill in the rest of the table, like so, with all the other values. So again, make sure you write it to 3 significant figures. For example, this one here, 36.0, the 0 in this position counts as a significant figure there. Okay, next part. Use the grid opposite to plot ln E against R. Draw a line of best fit on your graph. Okay, so we need to plot ln E against R, which means that we're going to be plotting these values and these values. So I'll just plot the first one. Okay, so that's going to be at 118.7. So there's 1, and then we need to go up to 18.7, so up to 15 is there. And then we'll look at the scale. So this is between 50 and 10, 20, which means it's going to be 16, 17, 18, and that's 18.5, which is pretty close. So that just there. Okay, make that a bit of a cross sort of shape. Obviously, you want to do that with a sharp pencil, preferably. So then we'll just use the magic of technology to reveal all of the other ones, like so. And if you've done this right, they should end up in a nice straight line. So then we need to draw a line of best fit on this. So I'll use the ruler function here. Just draw a line of best fit. Make sure that goes neatly through all of your points plotted to within 1/2 a square accuracy. Okay, so that's that question done. Right, next part of this question. Use your graph to find the values of K and A. Right, to do that I need to remind myself of what the original equation was. Okay, so the original equation was E equals K times A to the power of R. Now I need to find the K and the A. For that I'm going to use this form. So ln E equals ln K plus R ln A. So I'll just write that over here. ln E equals ln K plus R ln A. And what I want to do is compare that with y equals mx plus c. So the y is over on this side. So ln E is my y. The x was the thing that I plotted on the x-axis. Okay, well I was plotting r's on the x-axis. So that means this must be the x. So therefore the thing that's in front of the x must be the m. So that thing there is the m. And then the other thing, the thing that's on its own, is the plus c. Okay? And if you remember my equals mx plus c, the m is the gradient and the c is the intercept on the y-axis. Okay? So I need to find a gradient and the y-axis and the y-intercept of my graph. So I'll go back here and have a look to see if I can find a gradient. To find a gradient, I need to draw myself a little triangle in. So I'll do that kind of as large as I can, maybe trying to go through convenient points, but sometimes it's not always possible. So I'll just go perhaps from here and then across, like that. And I need to work out what the distance up is and what the distance across is. So I reckon I've done a distance across there of, well, that's 0 and then 7.1, 2, 3, 4, 5, 6. So 7.6 across. And distance up, okay, well, that's 40 there. So that's 41, 42. And at the bottom here, this is 15. So 42 take away 15, or 42 take away 10 is 32. So that's going to give me 27. Okay, so I've got to do 27 divided by 7.6 to give me the gradient. So let's just write that down over here. 27 divided by 7.6 gives me the gradient. So I use my calculator to work out what that is. 27 divided by 7.6. Use that button to change it to a decimal, and I've got about 3.55. Okay, so that's my gradient. I'll go back to here, have a little look at my equation, and I notice that the gradient, m, is equal to ln of a. So I've got my 3.55. It's not equal to a, it's equal to ln of a. So therefore, to find what a is equal to, I need to undo the ln. And the opposite of ln is e to the power of. So therefore, a is equal to e to the power of 3.55. So I'll type that in my calculator. So e to the power of 3.55 equals 34.8. Okay, so I'll go with that as my answer. So a equals 34.8. Right, now I need to find my value for k. And remember, k was all to do with the y-intercept, the plus c value. So better go back to my graph and find what the y-intercept is. Let's have a little look here. Okay, well, I'd say that that's pretty clearly intercepting at 15. So I reckon 15 is my y-intercept value. So comparing this, again, it's not that k equals 15. If we look at this ln k is equal to 15. So again, I've got to get rid of the ln, and the opposite of ln is e to the power of. So therefore, k is equal to e to the power of 15. And so again, I'll type that in my calculator to work out what that value is. So it's e to the power of 15, and then that gives me a really big number there. So I'll just write that number down. So that was 3269017. So that's a pretty big value. I'll just check whether I have to give it to any particular accuracy, and it doesn't say, so I'll go with that. Okay. Okay. So that's my values of A and K worked out. Let's move on to the next part. Part D. How much energy is released by an earthquake of magnitude 10 on the Richter scale? So let's just underline 10. Give your answer in standard form. Standard form means the kind of way when you write it as times 10 to the power of something. So I need to leave my answer in that form. Okay, so how much energy is released? So that was represented by E in my equation. if I just go back to what my original equation was, which was here, E is equal to K times A to the power of R, where R is the magnitude of the earthquake on the Richter scale. So let's write that down here. E equals K multiplied by A to the power of R. Okay, so I've got to work out E when R is equal to 10, okay, because it says magnitude 10 on the Richter scale. So I'm going to sub that value R equals 10 into the equation. I also need to sub in my K and my A from earlier. So let's just write down what they were. So K, that was here, 3269017. So 3269017 times by my A, which is written here, which is 34.8. To the power of 10. Okay, so I just got to whack that into my calculator. So I'll just use this this number here for K is already written there. Save me typing in all this big number here. It's already in there in the calculator. So all I need to do is times by 34.8 to the power of, which is this button, 10. Press equals. And happily, the calculator's given me the answer in standard form, so I'll just write that down. 8.51 times by 10 to the power of 21. And actually, if I'm a bit more careful about my rounding here, that should be 8.52, because this rounds that value up there to a 2. So 8.52 times 10 to the power of 21. Right, and then the last part, what is the number on the Richter scale that corresponds with an earthquake that releases 4.2 times 10 to the power of 7 joules of energy? So this means that for my equation, I'm now being given the other value. Instead of R, I'm being given E. So I know that E is equal to 4.2 times by 10 to the 7. So I sub that into my equation, and I get 4.2 times by 10 to the 7 is equal to K, which was this number, 3269017, multiplied by A, which was 34.8 to the power of R. And I've got to find what R is. So what I need to do is remove all of the stuff on this side of the equation, so that I can work out what my value of R is equal to. And so really I need to just kind of identify all the layers of the onion. So we've got this inside layer, that's where the R is, that's the center of the onion, and we've got sort of like the next layer is here, and then the very outside layer is this number here. So to get rid of that, the multiply by this number, I'll need to divide by that number. So I've got to do 4.2 times by 10 to the power of 7 divided by my big number, 3269017, and that's equal to what's left, which is 34.8 to the power of R. Okay, now I've got to get rid of the fact that it's 34.8 to the power of something, so I do that using logs. So if I make a bit more space for myself here, so using logs, I've got to do log to the base 34.8 of this thing, 4.2 times by 10 to the power of 7 over 3269017. And that is going to leave me then with R. So I better just whack that into my calculator to work out what that is. So to do that, let's clear the calculator. I need to use this button here, the log box button. So log bottom box is the base, 34.8. And then go into the brackets, and I've got 4.2 times by 10 to the power of 7. Just type it in exactly as it's written, divided by 3269017. Press equals, and I've got 0.7 there as my answer. And so that's what I'll go with.
just write that down finally. R equals 0.7. And I'm done.